I'll get started with my introduction. Just a couple of minutes ahead, and then I'll get into the slides right at 9. So I'm Greg Kazanza. I'm a program manager lead. I lead the SDN team in Windows networking, or mostly focusing on Windows Server. We do some other parts of Windows networking as well. Some of the sister teams do protocols. We do container networking, things like that. But my area of focus is on SDN. And I've been working on SDN in one form or another since the 2012 release, when we first introduced Hyper-V network virtualization. And if you haven't looked at SDN in Windows Server since then you're in for quite a change, because in 2016 we pretty much revamped the whole system and took the technology from Azure and brought that into Windows Server, and that's what we're now shipping. So with that, we can get started. It is now 9 o'clock. So yeah, so today I'm here to talk about things that we've learned and that will make your deployment successful. We shipped, as I mentioned, the new SDN in the 2016 release last fall, at about this time last year at Ignite. I was talking about how excited we were to ship it. And so we've been working with a lot of customers and a lot of you that have given feedback. We've learned a lot of things from a lot of your deployments. I've worked with some of you, even here in this room directly, to get your deployments up and running. And so that's what we're here to share today. So in this session, this is about Windows Server SDN, not Azure SDN. So if you're here for Azure, you're in the wrong room. It's OK if you get up and leave. I won't be offended. But what I'm going to talk about, a lot of the things that we've learned, what's made the customers that have been successful. I'm going to go through SDN architecture, so we're all on the same page. That's basically the first half of the session. I'll be showing some PowerShell, so if you're not comfortable with PowerShell, I'll try to explain things, but just giving you a little heads up on that. I'll show some PowerShell, try to show a lot through BMM. And I've broken down about 9 different things that are lessons you can kind of take home, things to do when you deploy SDN, through starting with deployment, getting your environment set up, but things you do after deployment, because those are some of the things that we haven't really talked about too much in a forum like this yet. So with that, so if you're thinking about deploying SDN, how many of you have actually deployed it so far and have used it? OK, a few of you. If you're thinking about it, as you can see, you're not alone. I brought up some telemetry that we're getting back from some of our customers to show where we're getting deployments around the world. And I counted the dots on here, found 68 countries. Now, a lot of these dots represent many deployments. It's not just one deployment per dot. So as you can see, it's really picking up. There are lots of people pretty much on every continent except Antarctica. No deployments there yet, unfortunately. Maybe the telemetry is not just coming through. But we have a lot of customers that are starting to deploy, and a lot of them are now successful in getting it up and running and are using it for real things. So this is a great thing to see. I also filtered out evals out of this query, so that even filtered out all of the Azure Stack deployments that are out there, which are added on top of this. Because internally, even though it's a black box, Azure Stack is using the Windows Server SDN that I'm talking about today. Now, there are some customers that we've published case studies. These are publicly available. Bright Solid in Scotland, they are a local professional services company. They do managed services and do some hosting for some of their regional customers. I work with them very closely. A lot of the learnings in here were from their deployment. Accutech is another customer I've worked with directly. They're one of the customers that is not using System Centers. They're deploying and managing entirely using PowerShell. The Gigabit is a hosting provider in Malaysia, so they are also up and running and have paying customers running their business on Windows Server SDN. Is there a German speaker in the audience who wants to say the fourth one? Go ahead, say it out loud. Thank you. In English, that is the Department of Justice for the state of Lower Saxony in Germany, if I got that right. They're a government organization. They're using it for, they have a project called eJustice. They're using SDN for doing a lot of their application development. So they spin up virtual networks to deploy their applications and test them in an isolated environment. And no list of customers is complete without a Microsoft example of how we dog food, as we like to say, our own software. CSS, Customer Support Services Labs, they use SDN to be able to spin up packages of what they call packages of Microsoft applications so that when a support call comes in, if any of you have called customer support, and they've gone and they need to repro one of your issues, they will spin up an entire environment that will have Active Directory, SQL, whatever application is running on SQL, whether it's Dynamics. They'll spin it up in minutes and have it up and running to save time so they can more quickly help you with your cases. So these are just a few examples. I'm not going to, you can go look at case studies online of all of them, except the CSS one doesn't have a case study online, but I'll talk about that one in here. Now, why are these customers using SDN? I talked about CSS Labs to be able to get things up and running quickly. It's the same thing for all of these service providers that have multiple tenants. They don't want to go and touch their hardware every time a new tenant comes in. So they want to get them up and running quickly, hands off, have it as automated as possible. A lot of these customers want more security. SDN, we hear a lot about companies in the news that, that aren't focusing as much on security as they should. Well, SDN is one of the ways that you can very dynamically bring in many more layers of security than you would typically have in a traditional DMZ front-end, back-end type network topology. Network capacity that scales with host. So a lot of times as you start to add Hyper-V hosts or virtualization servers in your environment, well, if you don't start adding your physical appliances that are in front of those servers, you're going to get bottlenecks getting into your network. At the same time, a lot of times you start to add more and more VMs onto your layer 2 networks, your VLANs. Those don't scale across the racks very well. So you want to try and get a physical network that has a layer 3 topology that still allows you to deploy your VMs anywhere you want and migrate them wherever you want. And that's one of the things that SDN also gives you that ability. Everybody loves PowerShell, so you can automate with PowerShell. So that's a great thing for server admins that are deploying applications and creating the network requirements that goes along with it. And reduce costs. If you don't have as much hardware that you need to wire, cable, maintain, scale out, that helps reduce costs. Is there anybody here that wants to increase costs? No? Okay, so I think you're all on board with this. I thought maybe some government organizations would. Just kidding, just kidding. All right, so how does SDN do this? Well, if you think about your traditional networking, and how you configure networking, if you want to bring in a new tenant into an environment or a new application that has unique isolation requirements, well, what do you have to do? You have to first start by creating a VLAN for that network. Well, that means going to the physical switch, configuring the trunk port to add that VLAN. Now, if you want that VLAN to go anywhere, you have to have a subnet with a router. So you go to your router, configure the router to have that subnet as well. If you want addresses automatically assigned, you go to your DHCP server. Now, if you want to get even outside of this address space that you've defined, you may have an edge device you have to configure. If it is multi-tenant, you may have a VPN device you need to configure. You may need to configure NAT so you can get out. And if you want to get in, you have to configure your load balancer. These are all separate physical devices you have to go and configure. And then, of course, security, right? You want to be able to restrict what comes in and what goes out. And so you have to go to your physical firewall. You have different admins for all of these, lots of different people you have to talk to, lots of people that have to work together. Well, with SDN, we want to make sure, we want your network, your physical network, to be as static as possible. We want to rely on just simple layer 3 constructs, defining fixed point-to-point routing between all of your physical devices. And then all of those very specialized functions we bring into the software on the Hyper-V host. Whether it's software that we have in-box in Windows Server, that we can do on the Hyper-V host in the virtual switch itself, or as roles in Windows Server, we have that. We also want to bring in third-party technology as well. There is very important technology that you depend on from vendors that are partners of Microsoft, load balancers, security appliances that are authorized for you to use due to whatever regulatory requirements. We want that to be brought in, but we want it brought in as virtual appliances, not as physical appliances anymore. And then by doing that, you're able to then go and configure all of this, whether it's a virtual network for isolation, the switching and routing that goes along with it in the virtual network, even the DHCP we automatically provide as part of that virtual network. All of this gets configured through the same management application that you use to deploy your VMs and your actual workloads. Whether it's System Center, PowerShell, or if you're using Azure Stack, then Azure Stack provides that front end through ARM. Now, this is all included, except for the third-party appliances, is all included with Windows Server Data Center Edition, so you don't need any extra software to do this either. They're all roles in Windows Server Data Center. So that's another great thing about our SDN. Let me show you just real quick. I'll jump into a demo so it's not all slides to show you what we can do with it, just to show you how easy it is. So here's a VMM environment I have. I have a couple tenant VMs I've already created, so we don't have to wait for those to get created. They are not connected to a network, and I have all of my SDN VMs that I need. I'll talk about those in a minute. But my hosts, 4 Hyper-V hosts, they're all configured to use SDN. They're all up and running. So the first thing I'm going to do is I'm going to create a virtual network for this tenant right here. I'll call it tenant 2. I'm going to go to my VM networks page. I've got a couple virtual networks here already. I'm just going to create a new one. It's as easy as going to create VM network. I'm going to give it a name. I'm going to call this tenant 1. Just click through the VMM dialog, say I'm going to use Hyper-V Network Virtualization, which is backed by the SDN in 2016. I'm going to define my subnet. Since this is an isolated network, I can give it whatever address space I want. 2.168.0.0, everybody's favorite subnet. And it doesn't matter if the other virtual networks that are out there for the other tenants are using it, because this is going to be completely isolated. I could have given 2 subnets, and then the distributed router, as I mentioned, will get created automatically. I can give it connectivity. I can say I want to use NAT to get out of the virtual network. As easy as checking that box. I select the pool that I want my NAT address to come from. Here's my public VIPs. Hit next, finish. So it's going to go now. It's going to talk to a new role in Windows Server called the network controller. It'll take a few seconds for it to go and create that. And then this virtual network is now created on the controller. Last thing I need to do through VMM is create an IP pool so it can allocate and keep track of addresses. I'm just going to do that real quick. Let's call this subnet 1. I'm just going to click through this using defaults, default address range. The gateway will be set automatically by VMM to point to the virtual network gateway that's automatically created. We'll finish that. And now this virtual network is created, and it's ready to use. Subnet should pop up in a second. There it is, or that IP pool. So now I can go back to my VMs, and I'll connect my 2 VMs to this virtual network. Go here, properties. This goes all the way back to Redmond, so there is a little bit of latency as some of this stuff comes up. My network, select my VM network, browse to the one I just created, which is tenant 1. This one's done. While that one's running, I'll do tenant 2 or tenant VM 2, so these two can talk to each other. Hardware config. Select the same thing. VMM will automatically allocate an address. It will automatically configure the DHCP through the network controller. And when this is done, up and running, I can go to my VMs. Might not be quite there yet. Make sure that second one is done. And the last 99% takes the longest. There we go. All right, let's see what we got. Make sure we got an IP address. Just make sure it's release. Whoops. Renew. So make sure we'll release the address. Make sure it has the current address. So this shows that the DHCP is actually configured. Oh. Oh, well, my typo. That's what that was. IP config. Good thing. OK, so we have an address. Now I'm going to assume that the other one is 192.168.0.6. Let's see if I guessed right. It might be .4. Let's try .4. Might have to go to the other VM to see. There it is. OK. So you can see in that amount of time, in what was only a few minutes, I went through. I created an isolated network. I got a router. I enabled NAT. I did a lot of those things you saw on the, the left side, that you would have normally had to go through and configure a number of physical devices to do. I did that all through System Center VMM, the same thing you need to create your application. So that's a great thing. I mentioned it's used in Azure Stack behind the scenes. Azure Stack is a black box, so you don't see it. But when you create a virtual network in Azure Stack, you're using the Windows Server SDN. So I'm not going to talk much more about Azure Stack in this session. So let's jump into architecture. What do we depend on to get this to work? Well, we depend on the Hyper-V host. This big empty box here is going to get filled up with SDN stuff in a minute. But we depend on the Hyper-V host, which will typically have a couple of physical adapters. Maybe it'll have more, but these days hardware is trending towards a smaller number of very high-speed adapters. And they're connected to a couple of physical switches. This is your standard software-defined data center host configuration that we would see. You start off by setting it up like your standard software-defined data center host. Whether you're using SDN or not, you generally create a switch. We have a new teaming technology called switch embedded teaming. So you no longer create the multiplexer adapter and connect that. The physical NICs go directly into the virtual switch. And then you typically create a couple of what we call host VNICs, which give you the Hyper-V host itself, the parent partition, access to the network through those virtual adapters. Now, the virtual switch, just like the physical switch, except your ports that you get on there are dynamic. You get an unlimited number of ports, essentially, whereas your physical switch has fixed ports. And so this is your standard host. You start off setting it up like you normally would. Now, to make it an SDN host, the key is this component called the virtual filtering platform. This is a switch extension that runs in the virtual switch that needs to get enabled for SDN to work. And this basically is a rules engine that can look at every packet, and if it matches a rule that's been defined in it, it can then take an action on that packet, whether it's modifying the packet or blocking the packet or allowing the packet. These are the type of things that VFP can process, and it's very highly optimized to do that, up to even 40 gigs or beyond. We take advantage of hardware offloads where possible. Now, just having VFP, that is a kernel driver. So by itself, it's not very accessible. So we have a number of host agents that also get installed. We have one for the network controller and one for the software load balancer for doing the load balancer configuration on the host. These are services. This and VFP get installed when you enable Hyper-V, but they're not configured and don't run until you've actually gone and done the configuration. So now the host agents themselves on a single host can't do much unless they're told what to do. For that, we have a new role in Windows called the network controller. So the network controller is essentially the brains of the operation that basically takes the commands from System Center or from PowerShell if you're not using System Center or from ARM. And these are commands like create a virtual network. It'll take that command, it'll put it in its own database, and then when it's time to add a VM to that virtual network, it'll figure out where that VM is, which Hyper-V host it's on. It'll talk to the host agent that's there, and then that host tell it, attach this VM to this virtual network. The host agent will then go and program VFP to make sure whatever is needed for that virtual network adapter that VM has will function. So this right here is the bare minimum of what you need to get SDN running. When you have that, you can create a virtual network. The virtual network itself will also get automatically what we call a distributed router. That router is available on every Hyper-V host. It's not a VM that runs or an appliance. It's part of the vSwitch itself. And it's running in an isolated compartment in that virtual switch. Now, that network doesn't do you any good unless you attach VMs. So, of course, you can attach VMs to the virtual network. And then your two VMs, in this case, Blue VM 1 and 2, can talk to each other on the same host. Once you can do it for one, you can create a second tenant. That tenant will also be isolated. You can start adding firewall rules now. And this firewall, because it's enforced on the port right there by VFP for all traffic that goes in and out of each of these VMs, you don't have to send it through an appliance. So you don't have to wait and only apply the firewall to packets that get routed. You can apply that firewall rules to even packets that are going between two VMs on the same vSwitch on the same subnet. Those rules will get enforced. And because they're enforced by the kernel of the hypervisor, the VM itself can't turn it off. So if the VM gets compromised for whatever reason, it can't turn its firewall off. So you can actually enforce outbound rules as well, which you can't really do effectively, in my opinion, with the Windows firewall. Some of the other services you then might want to have are load balancing. The VFP itself does the NAT for load balancing, but you still need a front-end component to be able to have the virtual IPs for the front end of your load balancer. And this component also is what makes the decision of which of those data center VMs, or DIPs as we call them, it's going to send the traffic to. And so we have another role in Windows now called the load balancer MUX. That you would also run typically in a separate VM, and it runs on the network, and it's what represents the front end of your load balancer VIPs. So really the load balancing is split between the MUX and the VFP extension that's running in the switch. Load balancer also does NAT, so if you do want to, if the VMs want to go outbound with NAT so that you can have a very private address space, it also serves that function as well. And then finally, if you just want to route in and out of the virtual network onto either a VLAN, across the site-to-site tunnel, or across the GRE tunnel, those are the three basic modes it runs in. We have the RAS service that runs in a VM as well, and the network controller can configure it to do those basic routing functionality. So and then finally, I should also mention that if those blue VMs need to communicate off of the Hyper-V host, they need to get, because they're on an isolated address space that the physical network doesn't know anything about, it needs to get encapsulated. So that virtual network is what's called an overlay. The physical network is what's called an underlay. And so we have to have what are called tunnel endpoints to be able to use VXLAN to tunnel that virtual address space from one host to another. And so when the host agent, when it sees that it needs to create a virtual network, it creates a couple of what we call provider address NICs that represent those tunnel endpoints, or VTEPs if you're familiar with that terminology. And so that's how when Blue VM wants to talk to a machine on another host, it'll get encapsulated with the VXLAN, tunneled across the physical network using the physical network address space that is very fixed. Even if it crosses physical subnets, the Blue VM subnet can span wherever it needs to go because of that tunneling. So that's the basic architecture. This shows, on a single host, but really you're going to have multiple hosts, and multiple of these components for high availability. So let's sort of drill into some of these to see how they actually work, starting with the network controller. So the network controller, you'll generally deploy 3 of these for high availability onto 3 different hosts into 3 different VMs. They all work together as a single network controller through Service Fabric. Service Fabric basically lets them act as a cluster. It does the synchronous replication for their database so that all 3 of them always have the same copy of the data. And it also makes sure that there is always quorum. If one goes down, then the other 2 will stay up and running. Now, Service Fabric uses a microservice architecture. So within each of these network controllers, we have a number of different services. There's one called the API service. It's running on actually all 3 nodes, but only one of those is primary at a time. It's where your REST IP, the REST interface that the management application will talk to, is located. So that API service, when it's primary, it puts the REST IP on a NIC on the network controller, and that's where all of your API commands go into. There are a number of other services, load balancer manager, virtual network manager, firewall manager. These all work together to make sure to implement all the different functions. Even backup has its own microservice that runs on here. Everything is a microservice. And so if one host goes down, you have your other 2 network controllers that will keep track of the fact, and they're all having heartbeats to each other. If that goes down, Service Fabric will automatically move that API service and make one of the standby ones primary and move the REST IP, so your network controller will continue to run. All right, let's go back to our diagram. Move on to the load balancer MUX. That's the next component we'll talk about. Now, one thing you may notice about the load balancer MUX is it has multiple network interfaces, typically. You have a management adapter, what we call the provider adapter, which is used for the VXLAN for the back end, primarily for the VXLAN packets. And then it has a front end that we call transit. Now, this brings us to our first lesson. These are things that customers have run into. You generally only want to have one default gateway on a machine that has multiple NICs. Now, it's not always the case. I mean, outside of SDN, these SDN deployments, there are exceptions. If, for example, you have 2 NICs that are connected to the exact same subnet or the exact same router, then that may be an exception, like your storage NICs may be. But generally, you only want one NIC to go out to the internet. And that'll typically be your management adapter, so you can get out. The one exception on here is the transit on the gateway. Because that needs to often reach, and that's considered the front end of the gateway, needs to reach out further than the rest, you would put that as your default gateway, and then you'd have static routes on your other NICs there as well. The main thing, as long as those other NICs have the routes they need to get to whatever it is inside the data center they need to be able to reach, you would configure static routes there. Now, when you deploy through System Center VMM and use the service templates, to be honest, it doesn't always put the right routing into these VMs, so that's one thing you need to be aware of when you go to deploy. Double check your routes to make sure you only have one default gateway and you have static routes on the rest of your NICs. One other thing we ran into a long time back, actually before in 2012 R2, is we got the V4 routing all set up correctly at one customer, and then things stopped working a little later. What we realized, they had IPv6 enabled at the same time, and it was actually the IPv6 routing that ended up being used, and it had the same problem of having 2 gateways, and the wrong one was being picked, so that applies. The other lesson that is also important is to have only one of these IPs, your management IP generally, registered in DNS. This is especially common on the host VNICs, where you may have other physical adapters that are connected to other networks. We have this commonly in the Microsoft Corp network. When we do lab deployments, we'll have a Corp net adapter, and then we'll have a lab management network. When we have 2 of these management networks, they may go to different DNS, and then you have 2 names registered in DNS. Which can confuse the network controller, because at times it will do lookups to see what name are you registered under, and it may get very confused as a result. So make sure you only have, especially on your host, one IP registered in DNS. All right, back to the architecture. So the load balancer, That is generally deployed also. You want multiple of those so that you can survive failures. Now, its high availability story is completely different from the network controller. It doesn't use service fabric. Because it's actually processing part of the data path, you want it to be even more reliable and even more scalable than the network controller. You don't want to have just one primary that's processing everything. You want all of these to be able to process as much as possible. So we actually rely on the physical network actually to do the load balancing and the high availability for these. We do that through BGP. We peer these muxes to the physical network so that they then look like routers to the physical network. So to your physical switches, we require L3 physical switch and L3 configuration physical switches. They see these load balancers as routers. And so once they peer, now these muxes can start to advertise their virtual IPs. When they do that, they advertise every virtual IP from every mux as a /32 subnet. So mux 1 will advertise the same VIP as mux 2, and then the switches will get both of those muxes in their routing table. Well, the nice thing about that is then, when a packet comes in wanting to go to that VIP, these switches can now pick either mux. And so they'll do a hash. They use what's called equal cost multipathing, so they had 2 paths to get there. Use ECMP, and they'll just automatically start distributing the packets across these 2 muxes. Hey, guess what? You add a third mux. It will also peer, advertise the same route. Now it will start getting used automatically. And so all these muxes are all active. And scaling out is just a matter of adding more muxes on more hosts. So you're actually literally scaling with the number of hosts you have. So that's great. You are still limited on a per TCP connection limit to what one mux can handle for that. So if you have a single TCP connection, you'll be limited by what that mux can do. But your aggregate throughput is only limited by the number of muxes you have. A single mux generally can get around 5 gigabits per second of throughput is what we're seeing on these. Now, of course, that's for the load balancing. What happens when there's a failure? Well, BGP also has a nice mechanism called a keep alive. So there's also constant probing between the switch and the mux. If the mux doesn't respond quickly enough, as may be the case if the host it's on goes down or the VM itself goes down, then that keep alive will fail, and the switches will automatically remove it from the routing table, and it'll stop sending packets. So the switches then are smart enough to also do the failover when a mux fails. So that's the front end. Let's say the switch picks the left mux to send a packet to. The mux's job then is to pick one of the back-end VMs to load balance to. It will then encapsulate it, send it out on the provider NIC, where it'll get to the host where it's destined. There it'll get rewritten, so the destination is no longer the VIP, it'll be the DIP. That's where the NAT operation is, and that goes to Blue VM. Having the NAT happen on the server itself is not too exciting until you start to look at the response. Because on the response, this Blue VM can now send the packet. It'll go in the vSwitch. Its source will now get rewritten from the DIP to the VIP, and then it can go directly to the physical network. It doesn't need to go back through the mux. And so here we're even further taking load off of these mux appliances and pushing more of that capacity out to the physical NIC. That's pretty cool. All right, let's scale back to our original diagram. Let's drill in on our last component, which is the RAS gateway. So the RAS gateway itself also has an availability story. You're not going to have just one of them. You're going to have multiple of them deployed as well in case one goes down. But because this has VPN tunnels that are stateful, we can't rely on the same mechanism of just letting the switches pick one at random. So we have the network controller decide which one is going to be active and which one is standby. So you get to define how many of each you want, and the controller will then keep track of which ones are healthy and automatically keep the number of active that you want and the number of standby that you want. We call this M-is-to-N redundancy. So in a 1:1 example, you have one active, one standby. The active will have all of the connections that are needed. The standby will be idle until the active one fails. If you deploy another gateway, well, then you can have 2 active, 1 standby. You can adjust that number as you want when you deploy the pool of gateways. These are all put into a single pool. Now, this presents an interesting problem when you have 2 active gateways, because now each of those are going to have their own front-end IP. But you don't want to have your tenants tied to the IP that's on an individual gateway, because that presents additional problems when you want to scale out even further, because now you have tenants tied to that IP for their VPN tunnels, and you have a new gateway now, and now it gets a new IP. Well, how do you get tenants onto there to free up the capacity? If only there was some sort of component that could balance the load between these VMs with a virtual IP. Oh, wait, we have one. It's called a load balancer. Well, this is why our gateways depend on the load balancer you deployed first, because we make the site-to-site endpoint that all the tenants connect to a single IP that is a VIP on the load balancer. So that's exposed to the virtual network, advertised through BGP, just like all the other VIPs. all of the tunnels for the tenants will connect in. It decides which gateway to send to based on the source IP of the tunnel. That's how it knows which tenant is connecting in. That's also why if you do have a tenant that wants to create 2 tunnels from the same source IP, you can't do that. So if you're wondering if you have 2 Azure Stack instances and you want to connect 2 tunnels between the 2 of them, you can't because they will both use the same source IPs to talk to each other, and then the 2 sides can't tell which tunnel is which anymore. So that's just one limitation we have today. Once it comes in, the load balancer will have the rules that the network controller tells it to find the right active RAS gateway. That's where the IPv2 tunnel, if it's a VPN tunnel, this is for site-to-site specifically, gets terminated. And then that gets transitioned onto a VXLAN tunnel to go to the actual VM where the packet's destined. Now, since that IPv2 tunnel is stateful, the response path from the blue VM does have to go back to the RAS gateway to go back, using VXLAN, of course, again. But then from there, direct server return gets used. There's actually the NAT operation that takes place there, and the packet goes straight onto the physical network. The RAS gateway also supports GRE tunneling. It's a little different. It doesn't need to go through the load balancer much because every tunnel, because these are using data center IPs generally, and so there's a much greater number of them available as opposed to the public internet routable IPs that you would typically use for site-to-site VPN. So the way it works is it actually advertises these GRE VIPs, as we call them, to the physical network, also using BGP in the same way the MUX does. The RAS gateway also uses BGP to do that. And so the physical network can actually just tunnel these GRE packets directly to the active gateway that's doing the termination for that GRE tunnel. So it'll do the incap bcap, and then on the back end, VXLAN happens the same way. The last mode that the gateway runs in is forwarding. This is the highest throughput method that you can get. You can get almost 10 gigabits of throughput with forwarding. And with forwarding, you're essentially routing from the virtual network onto a VLAN. If you may have a traditional physical network that has a DMZ that you want to route onto, or a tenant has physical hardware in your data center that you want to route to that physical hardware. Well, you already have some VLANs there for your infrastructure, your transit HMVPA management VLANs. They're trunked into the physical host. That's what that big red cylinder is. That's your pipe coming into your virtual switch from the physical NICs. They're trunked in from the vSwitch. And if you have these tenant VLANs, you would also trunk those into the Hyper-V host where that RAS gateway is located. From then, once the controller gets configured to say, oh, I need to have this virtual network, for the blue virtual network, connected to the blue VLAN, the controller will then be responsible for configuring that VNIC for the front end of the gateway into a trunk mode as well. So it's a virtual trunk that now has these tenant VLANs coming into it. The network controller handles doing that for you automatically. You don't need to do that on the RAS gateway VM. And so that trunk will come in. The network controller will give it an IP on that network, and it'll set up the next hops to be able for the RAS gateway to route to whatever the router is on the physical network. And you'll be able to route in and out of the virtual network, just like any other router is able to do on any other network. So that's the last mode for forwarding. Oh, this just shows we have a compartment in the gateway that shows it has its own routing cable, so it can route between those 2 NICs. And that's the inbound path. All right, so that's the architecture. That's everything there is to SDN. So how do you actually get it deployed? When I've talked to a lot of customers, one of the first challenges they face is that I'm talking to a lot of server admins. Server admins now have to figure out how do we get the network configured, because they have network admins they need to talk to. We told you several times, you just do not listen. Stay out of the network sites, and all you do is cause trouble. Have any of you had exchanges like this with your network admins? This is an actual quote from an email exchange I just happened to be included on between a server admin and network admin. These are not unusual, all right? Server admins a lot of times have a hard time, getting the message across of what they need, especially when they're trying to bring up, they see the value of SDN, but the network admins don't, because they're used to a physical world. So I'm going to try to help you understand how to communicate these requirements. So I think, are any of you in here network admins, first of all? Okay, well, hi. So this is how all of your server admins will be talking to you. For everybody else, this is how you'll be talking to that person. So you want to speak the language that they understand. So talk in terms that they understand. Talk about the routes that you need, the subnets you need, the VLANs you need. So that, so it's important that you know what you're asking for and ask for that using their terms. You're not asking for them to implement SDN. You're asking them to do some very traditional networking configuration for you, right? You're asking them to configure VLANs, configure routes, and BGP is probably the one area that probably is the more complicated And sometimes they do have some pushback. They don't want the Microsoft software peering with their physical network. But the main thing to communicate is that BGP only needs to go to that top of rack switch. Maybe an aggregate layer if you have an aggregate layer between your SDN racks if you have a multi-rack environment. Beyond that, they don't have to use BGP. They can go off to OSPF, static routing, whatever. You don't have to have this BGP that's used for SDN connected to the rest of the BGP world if you don't want to. But you do need BGP in the top of rack switch, so you need to ask for that. BGP requires a few things, what's called an autonomous system number. You'll need that in the switch. You'll need an autonomous system number for anything that's peering with that switch, which includes the MUX and the gateway. You'll need to know the IPs that you're going to peer with as well on that transit network. That's what you're actually connecting to. And then you're going to actually need some subnets you can actually advertise through BGP. You'll need the public VIPs. We have a set of private VIPs that we use internally, and then the GRE VIPs that we use for GRE tunneling. And so you need to, when you ask for these, get ready to answer the question of why do you need these? Well, you just saw the architecture, so now you can explain, here's why we need these and what you do. But that's what you ask for. Where do those things go? Well, let's talk a little bit about where you configure things. As a server admin, you typically configure the Hyper-V server. You'll do the very basic networking there, configuration of that, which consists of the virtual switch, switch embedded teaming. You'll run the scripts needed to enable SDN on there and get that up and running. If the network admin owns that top of rack switch, well, then they'll start to configure things starting from the bottom and working up. If you're using RDMA, they'll need to configure the quality of service. That's very important, especially if you're using Rocky V2, PFC ETS. Those things are very important to get configured and right. You won't notice problems when you first start to use, if you're using S2D or one of the storage technologies that rely on RDMA. But once you start to push load, if you don't have things configured right there, you'll get packet drops and things will go bad quickly. You need to have jumbo frames. When you start to encapsulate with VXLAN, that makes your packets bigger, so you need jumbo frames wherever those VXLAN packets are going to go. Again, another thing you won't notice initially, but as you start to push bigger packets, bigger load, you'll see fragmentation. Not a good thing. You need BGP to get configured there, so the MUXes can peer. You need routers configured for your subnets. All of those subnets, even for the infrastructure, the management, the HNVPA, and the transit network need a router configured on them, especially that provider network. For a direct server to return to work, the virtual switch has to be able to send the packets to a router. That router is the PA router. And so if you don't have a router on that HNVPA network, that middle adapter on the diagram, those packets won't go anywhere. That's been another problem that customers run into. You need subnets, you need VLANs. You need to make sure that those VLANs span across the two switches in a two-switch configuration. So there are technologies called VLT or VRRP. Depending on which switch vendor you use, they'll have different names for it. And then, of course, you need to configure the uplinks to your aggregate or core. If you have an aggregate, as I mentioned, you need to have BGP there, also jumbo frames, because your VXLAN packets and your BGP will go up to there. You need to have your point-to-point links if it's an L3 network, because we often recommend that you use at this point. You don't want your VLANs to go up to your aggregate layer ever, if possible. And then you go up to the core. From here, you're basically going to rely on whatever your network admin will basically use whatever they traditionally use to configure their core network. You don't really have anything specific there. They can optionally send BGP up. One thing that often gets forgotten is that core network needs to know how to route down. And so they need to make sure that they have the route for those VIP subnets that you asked for to point down. If they let you advertise your BGP all the way up, then it'll just show up automatically. If they don't, then they have to have their own configuration that shows to point down for those static routes down to at least to your top of rack switch from there. And then on the edge firewall, some of our customers have actually now started bypassing the edge firewall, because that creates a bottleneck, because these typically have much slower adapters than they have on their servers. And so they actually will bypass the firewall and rely on the SDN firewall for their tenant traffic. So that's it. That's your one-time hardware configuration. That gives you now the ability to do, and that's the one time you talk to your network admin. That gives you the ability to do NAT, inbound and outbound, load balancing, site-side VPN, GRE tunneling, all the basics of what you need for SDN. It's a one-time configuration. You don't have to touch it again after that unless you run out of VIPs in your VIP pool, and then you need to ask for another subnet. That's the only time you need to go back to that one-time config. Now, if you do use forwarding, as I described before, you do have to do additional configuration per tenant, per VLAN you want to forward onto. And that's basically doing a little bit more of the same, just creating a VLAN per tenant top rack switch and setting up the routing for where you want that to go. That tenant VLAN may have its own BGP that it needs, or you can use static routing. It's up to your tenant or you to decide what you want to do. All right, so let's do a quick example of how you actually get this up and running. Oh, actually, I skipped my lesson before we get to that example. How do you get this deployed now? You got everything you need from your network admin? Well, one way is you can go to VMM UI and start to click on all the buttons and enter things, everything in every dialog and UI. That's great until you make a mistake on the very first dialog, put the wrong VLAN ID in, get 20 steps later and realize, oh, I have the wrong VLAN. Now you have to undo and do it all again. Hope you don't make another different mistake. So we recommend using these scripts that we make available. We call them either SDN Express if you're not using VMM, or VMM SDN Express. These basically, you populate your configuration you get from your network admin into one config file. You run it with one command, and it's going to do everything needed to configure SDN. And the great thing about it is the VMM SDN Express will attempt to undo automatically. You may have to do some manual cleanup, so you can rerun it again if something goes wrong, in which case it's just a matter of fixing it and rerunning it. The SDN Express, if you're not using System Center for Management, let me log in. We'll do the same thing, but without VMM. OK, switch over here. Let me switch to the correct server. So I've got a different environment that does not have SDN deployed. And we will run with that. OK, so here's a VMM environment. There's no SDN, no VMs, nothing running on here. But I do have VMM set up, and I have my host added. They have their basic configuration. So when you download it, VMM SDN Express from GitHub, you'll get a number of files. You'll expand them. You have a number of service templates, one for each of the different types of VMs. Here you go, Gateway, Network Controller, SLB. There's some helper scripts for doing things after you get deployed, like how to create a tenant VIP, add virtual networks if you want to automate some of that. But the main script is the VMM SDN Express. This is the script here that you'll run. And then you have your sample config file, and then this example is the one that I've already filled out. So if we look at those, here's a sample config. And basically, it's just a matter of filling in into this file. Well, what VHD are you going to use? Where's the VMM library? All the things that you would normally enter in through the UI. You kind of are guided through what parameters to fill in. A lot of this is just standard VMM stuff. What host group are you going to put it into? Which logical switch? It'll even create the logical switch for you. It'll create all the uplink port profiles. If you're familiar with VMM, it'll create the logical networks. Here's where you actually define those. So all that info you get from your network admin that you've asked for will go here. And you just fill all this out. And there's some credential stuff at the end as far as what credentials you need. And things like that. And then finally, are you going to do network controller, SLB, or gateway? So this is the one that's not filled out. Here's my example with just some of these values filled in. And so you can see it's very straightforward. Deploying then is simply a matter of taking that config file, running vmm express.ps1, passing in that config file, pressing enter. And about 30 to 45 minutes later, this will take a minute to get going, you won't see much happening in here, but you'll eventually get your environment up and running. If you do go to the jobs view, you'll see lots of jobs actually will start appearing on here. You can see it's already started to ignore that. That was some old garbage collection. You'll see some logical networks will start getting created, creating the VM networks for that. It's going to create the logical switch. So if you click on running, you'll see stuff will flash that it's happening as it's going through. We're not going to wait for this to do everything, but basically what you end up with when you're done is that environment that I showed you at the very beginning, the one that is ready to go, and it's ready to use when VMM SDN Express finishes. Now, if you get an SDDC premium solution from one of the hardware vendors, they will have run this for you automatically and gotten it up and running. They'll, of course, ask you questions, a survey to be able to fill in that config file. Azure Stack itself does the deployment for you also, so you don't need to worry about running that if you have Azure Stack. Oh, there was my demo. OK. Lesson 4. Things don't always go as smoothly as you'd like them to with the deployment. And we've learned that. We've learned things from a lot of you as far as what can go wrong. And we build a tool that will try and identify some of those for you so you don't have to go and do the digging around yourself. We call this SDN validation tool. It's available at that URL, aka.ms. I'm going to be referring to a lot of these aka.ms links, /SDN validator. You download this, it's an executable you run. I'll show it to you actually in a second. And it does all sorts of checks. I'm not going to drill into these now because I'm going to show it to you. Things for the host and the network controller that we've learned. Now, there's lots of things that we still don't detect with this tool. We're going to improve it over time since it's available on the download center. We ship it out of band, so we can update it frequently. So let's actually jump into to my demo environment here, and I will show you this validation tool in action. So switch back over. This is the same VMM environment I used at the very beginning. Go full screen again. Here it is. And I've already extracted the validation tool. I got on my C drive. Oh, that's my SDN. Here it is. OK, I've got it here in validation. I've extracted it. There are a number of files. And the main one is the executable ncvalidationwizard.exe. When you run this, it's going to bring up a wizard. It'll ask you for some information. Just hit next on the first one. Ask you for credentials. Since I'm logged in as the admin, I need to, in order to be able to connect the controller, I'll just do that. You need the network controller name, ncservice.contoso.com. If you don't remember what this is, you can look at VMM on the network service configuration, because that will have it there. And then you can import the set of servers you have from the network controller. So here it's actually going to go out and try to talk to the network controller. Very first thing it's going to do is try to get the list of servers from there. And if everything goes smoothly, at least you have your controller up and running, it will fill out that list of hosts. If you don't have your controller up and running, you can still add these servers manually, and it'll still go look at the host and try and figure out what's wrong with the host, why your controller itself isn't working. Hit next. This looks very much like the cluster validation wizard, if you're familiar with that, just a confirmation. And then it's going to run. It's going to run all these tests automatically. Hopefully, most of them will pass. You may get some that won't. In this case, we're going to get 2 that will fail. One is jumbo frames. I don't have jumbo frames enabled. And the other one that will fail is, which is somewhat normal, is that there are some port profiles that aren't configured. Your gateways, if they don't have any tenants on them, will have some port profiles that aren't configured yet, because the network controller hasn't gone and configured that transit NIC in the way it needs to, because there are no tenants that need it. So you'll see that here. That's the bottom red one, where it says verify port profiles are configured. This test reported some warnings. That's because those gateway VNICs, and when this finishes, we'll bring up the report. Those gateway VNICs haven't been configured by the controller yet. So we're almost done. This environment is healthy, because I just showed it to you earlier, so generally things will be doing OK. The one thing that isn't here is jumbo frame. So I can view the report, and this just brings up an HTML page that shows you all the things that it detected. And you can click on the links to find those that failed. Here's the jumbo frames warning. And it tells you where it detected that the hosts themselves didn't have jumbo frames. So that's a really cool tool. Use it. Let us know if it works for you or if it doesn't find the things you need. We'd like to know. Which brings me to my next lesson is, how do you contact us? You need to know how to provide feedback. At some point, you may not get the answers you need on your own. Your first line of defense, especially if you are in production and something goes wrong, is call support. They are the ones that need to be able to help you. They have an SLA to help you. If you don't get what you need out of them, send an email to the bottom link, the SDN feedback. That SDN_feedback@microsoft.com is an email address. I will get an email when you send an email there. My manager gets an email when you send an email there, so I'm highly motivated to make sure there's a response that comes back. All of our tools are on GitHub. You can report, that I just showed you, the SDN Express. You can report issues directly on GitHub. If you want to, you can even contribute to those tools, to the SDN Express script or the VMN SDN Express script. Fix some bugs yourself if you'd like to. That's also available to you. We also do some things on Twitter. We have a Microsoft_SDN. It's hard to see the underscore there, but there's an underscore for Twitter as our Twitter handle. We do some stuff there as well. We also monitor if anybody also links us. Our documentation is the common question I get is, oh, how do I do this? And I say, well, it's documented on, well, it was TechNet, now it's docs.microsoft.com. That aka.ms/sdn-docs link will take you directly to our documentation. We have a lot of good stuff there, especially on troubleshooting. If you want to do some of the troubleshooting steps manually, we have a great troubleshooting page there as well. And if you didn't write all of this down, the one thing you should write down is that aka.ms/contact-sdn link. That basically has this same information on there. If we ever update any of this stuff, we'll update that page as well to make sure it's current. So those are the ways you contact us. We want to hear from you, especially even if you're successful in your deployment and you just want to say, hey, everything works great, let us know. We like to hear that sort of thing. But if you do have feedback, feature requests, things you want, send SDN_feedback, and we'll make note of that. We may not all deliver it as quickly as you want, or possibly maybe not ever, but we'll at least put it in our list, consider it, and if enough of you ask for it, most likely we will do it. So it just may take a while. All right, what's our next lesson? Lesson 6. All right, you got everything up and running. Everything's successful. You may have gotten some help from us if you needed it. Now you need to stay current, because guess what? We've been making fixes, and we've been actually making improvements to what we shipped last year over the last year. And we continue to do so. Every month in the monthly server updates, we have a lot of fixes that come out. We actually shipped a new feature, Backup Restore, that we didn't ship at RTM last year. We shipped that at around, I think it was in March or April updates. That's now available for you to be able to back up the network controller and restore it. I'll show you that actually in a few minutes. We improved the failover speed of the gateways dramatically for the site-to-site VPN connections or any of the connections you use. Those used to take minutes to fail them over. Now it's a matter of seconds. We discovered some issues with inconsistency with how we do our ACLing, so that if you defined ACLs in our SDN, especially with Azure Stack, and you did the same thing in Azure, you would actually get different behavior. We fixed that. We fixed a lot of other bug fixes as well. Now, installing the patches and the updates isn't just as simple as going to Microsoft Update on every machine, hitting update, and going getting a cup of coffee and you're done. You need to make sure your SDN environment stays healthy, and that's most important for the network controller itself. There's some things you have to do there that I'll show you. You also want to try and do it in a way that minimizes your tenant downtimes. Remember those gateways that are having those IPsec connections, those are all served by a single gateway VM for each connection. And so if you need to reboot that gateway VM to update it for whatever reason, that gateway connection is going to fail over. You can't avoid that. Hopefully it'll be within seconds. It'll come back up. But you don't want to do that then multiple times as you roll through your set of Hyper-V hosts, fail over this tenant to the next host, then you patch the next host, failed over again, and you keep going through. You don't want that to happen. So I'm going to show you how to do that with only one failover. So 5 steps to getting patched. First step, update where you're running your management console from. This is wherever you have the RSAT-network controller feature. Turns out we actually have some updates to the PowerShell that actually affect some of the update commandlets themselves. So if you are doing your updating from a machine that isn't a network controller itself, update that machine first. So you have the latest PowerShell wrapper. Step 2, update the network controller cluster. Now here is where it's critically important that you maintain quorum of that service fabric ring at all times. If you patch one of the network controllers, as soon as the VM comes back up, you go and patch the next network controller. That first VM may have not synchronized its state completely before you went and rebooted the second controller. And now you're going to lose quorum, because now you have only one controller that's actually active at that time and 2 that are in inconsistent states. So it's critical that you go through one, check the state, make sure it's up, then go to the next one, the next one, the next one. And that's how you make sure your network controller stays healthy. Let's go through this. This is like a stop-motion animation demo. Got some updates coming in on your network controller. Go ahead and hit install on your first network controller VM. It'll say restart required. Before you hit restart here, you should go to your network controller and run the get network controller node commandlet. You'll see, here are 3 network controllers. They are all up, so it's OK to hit reboot on that first controller and reboot it. When you do that, you'll see it'll go to down. You'll be running this on the controller you're not rebooting, obviously. It'll go down, and your controllers will still be healthy because you have 2 of them that are up. They're all maintaining quorum, constantly synchronizing. Whatever services run around the down one are now on the up ones. Even if that VM that you've just rebooted comes back up, you have to keep checking this until you see all 3 of these go back into the up state. At that point, you can then go on and do your second network controller. Now, just getting the updates installed doesn't actually update your controller yet. Service Fabric is going to wait until all of your controllers have the consistent set of updates available and installed before it's actually going to go and load those updates. And so you can check that by looking at the version number. You see down at the bottom of the screen, there's that version 10.1.8. That's the version of the network controller microservices that are running in the network controller. Now, it checks about once per hour to see if there's been an update that's been installed and is consistent across all the nodes. So after you update your controller, you may not see any of the new functionality or the new fixes until that 1 hour has passed. Now, you can force it to happen by doing update-network controller, in which case it'll go and do the check immediately. This is that command that I mentioned that we actually updated in one of the updates. So if you run this update network controller remotely and you didn't update, it may actually be missing something. And it'll tell you what the new version is here. It updated it to the controller to 10.1.10. And then if you do the get network controller again after that, you'll see at the bottom there 10.1.10. It's now been updated. So now you know you're up and running with the current version. Updating your muxes, this is probably the easiest component to update. Because these are all active-active, you can basically bring any one of them down, and the other ones will just automatically take over. If there is a packet in flight, that packet may get dropped. If it's a TCP packet, it'll just get retried automatically. If it's UDP, you're out of luck. That's just the nature of UDP. But the other muxes will immediately take over. So, but important you do one at a time, or if you have a lot of them, you can probably do two at a time, as long as you have enough to take over the load that those that are out are going to handle. They're all stateless, so there's nothing you need to worry about synchronizing or worry about any sort of quorum that needs to be maintained. So just go through your muxes, do those one at a time. Now your hosts and gateways. This is where it's important that you do these synchronized. You want to make sure that you do the gateway hosts that have your standby gateways patched first, along with the gateways that are running on that host, so that you basically patch the node that is not doing anything first. Then you go to the next node that has active gateways, and those will fail over to the one you just patched. Now they're going to stay there and continue to run until your next patch cycle. Now you have one now that's now empty, and so you can patch it, and you just roll through one at a time. Now the challenge there, though, of course, is finding out which of these hosts and gateway VMs is your standby gateway. For that, you generally have to go into VMM PowerShell or into the network controller PowerShell. For that, I've actually recorded a video that will show you how to do that with a script. Let's actually run that. So here you have a VMM environment. We'll zoom in on that so you can see it. I have 3 gateways running. These are, I believe I have 2 active and 1 standby. We're going to go to the gateway service right now so you can see how we have that configured. So if you go to the gateway manager role, go to the properties, and click on that gateway manager role, you'll see nodes reserved for failures. We have 1 reserved. So of these 3 nodes, 2 are active and 1 is standby. So now let's go through and figure out which one is the standby. And for that, there's a script here that we're going to take a look at. And just pause this here for a second. And what this script is going to do is it's going to do a combination of VMM PowerShell and network controller PowerShell in order to figure out what's active. First thing it's going to do is it's going to query the network controller, and it's going to do the get network controller gateway commandlet, and it's going to query the property that says which one is active. That's the first line. What's that again? Draw node. So it's going to query that, and this is going to return the active gateways. Now, there's another object in the network controller called a virtual server that actually has the name of that gateway. That's the next thing that you need to query. So you need to get the list of virtual servers. And then what you're going to do is you're going to iterate through the list of passive gateways that got returned. So here it's not equal active. So it's returned the passive ones. You can iterate through, find out which of those virtual servers are the passive gateways. And from there, you can get the server name. This right here is the management address here. And then that is going to then let you go and get the VM from VMM, which will then tell you which host that VM is running on. So let's let this script finish. So it'll run, and after a few seconds, so I don't really run that one. Okay, let's do this again. This is a fast demo, so we'll just get that to go. My touch screen isn't working. Oh, I know I am in pen mode. There we go. Okay, let's let this run again. So I'll bring up the script again. It'll just take a few seconds. Oh, we still have going? There we go. Now we're going. Okay. We'll see this again, just so you didn't get it the first time. See it querying. Get back to the script. And then when see the active gateways. Okay, here's the script, so it's going to run now. And this will just take, well, it takes a few seconds for it to run, but it'll then tell you which one's the active. So once you determine which one is the standby node, we have to enter in the credentials, you go patch that one, patch its host, then you run the script again, because now you need to find the new standby node, and or run these commands again. You don't have to actually run the full script, if you can just run the queries manually. There you can see this one, in this case, gateway VM3, which is running on host 22.4. So those are the first ones you'll patch. All right. So the fifth step of the patching process leads us to the next lesson, which is after you patch, take a backup so that you now have a current state of the network controller database. The reason is because after every network controller version update, we may have made some schema changes to the database, and so all of your previous backups may no longer apply. So you need to back up after you patch, and your network controller has been updated so that you now have a current backup. Now, why can't you just back up the network controller VMs? That's what, we actually, as we were building this feature, some people were asking internally. I've got to back up the network controller, I'm happy. Well, it's because that service fabric needs to have a majority of nodes with an exact duplicate copy of the VM. But the nature of distributed systems is that when you do a backup, even if you give all these machines, tell them to back up at the exact same time, they're not going to be backed up at the exact same time. There's just going to be differences. They're all running on different Hyper-V hosts, and they can be microseconds apart, but that could be enough of a difference to break quorum. And so, here it is illustrated, right, in pictures, right? You issue all of your backup commands at the same time. Just so happens your network controller 1 backs up first. That's great. That big blue thing in the middle is your database. It's called IMOS, internally what we use. Every network controller VM has its own copy of it, but it looks like one big database to all of them. All right, backup network controller VM gets a copy of the database at the current time. As soon as that backup completes, somebody makes a change to the database. You have now database version A, at which time second VM gets backed up. I think you can see where this is going. That VM2 now has database version A backed up, which is different from VM1. At this point, database version B gets created. Somebody writes something different in there, and now finally, network controller VM3 gets backed up. You now have 3 different versions of your database. Which one is the right one? Nobody knows. So that's why you have to back up the network controller separately. Now, if you have all of the latest updates installed, you will have these backup commandlets. If you use the actual RTM that we shipped last year as your image and didn't install any updates, you will not find these commandlets. These are your get network controller backup, get network controller restore. You have to do the backup and restore through PowerShell. That's the way it is. What you need an SMB share. That's where we'll write the backup to. So you need an available SMB share. And we need credentials that we can use to do the read and write with read and write permissions for that share. Your basic backup workflow, which you're going to be doing this frequently. There's no harm in doing it multiple times a day, even if you want to. You do your backup of your network controller VM. Ideally, you back up your VMM at the same time. So you also want to try and keep VMM and your network controller in sync as possible. If you don't, then you're going to have to do some manual reconciliation between the two. So try to do those at the same time, too, if you can. You'll have a recovery point objective that your organization has. If you pass that point, then do another backup so that you know how much recovery time you have. If a disaster occurs, which hopefully won't happen very often, if ever, then you go on to the restore workflow. So let's do a backup. We'll actually go to my demo environment here. And we'll run a quick backup here. Disorganized a bit. Oh, actually, go back to the OK. So the script, and this script is available on docs.microsoft.com on the link I gave you earlier. I have to get to my taskbar so I can get to my ISE. OK. So these scripts are available on the documentation, so you can just go there to see how to do this. And basically what you're going to do is you need to get the credentials that you're going to use, because you're going to use that in the backup object. You then, if you haven't created those credentials yet, you'll create that for the first time. There's a credential object you create in the network controller. Once you have those credentials, then you create a backup object. So you have backup properties that you create, and that basically contains the URL that you're going to write to. In this case, I have a share on my VMM server that I'm going to write my backup to, and I give a unique directory for each backup based on the current time of the backup, and then you give it the credentials to use, which is in that credential object. Once you create it, then the credentials are securely stored and encrypted, so those are stored. And then you do new network controller backup. So if we run this, and let me bring up the share directory here. You can see I already have 3 backups from some of my test runs earlier. Let's just run this again, and we'll see a new backup get created. If we hide fast enough, you'll see that 4th directory will pop up there in a second, and that then has all of the files that have been needed for the backup. So let's wait. It always takes the longest during the actual demo. Normally it takes, there it is. It's pretty fast. Our requirement was that we could do the backup in under 30 seconds, so you're going to do another one. You'll see there will be another backup, and there's another one. And so that's it. You can query this object that got created, this backup object, using the resource ID that you passed in when you created the backup object to query the state and see actually what objects got backed up. But you can see there's a whole bunch of stuff that gets put in there. Generally, don't touch the stuff that's put in that directory if you ever want it to actually work again. Now, of course, a backup is no good unless you've actually tested it. So this will hopefully be the only time that you actually need to do a restore. But the restore process you can see here is somewhat more involved because you have to actually kind of break things in order to bring things back. Now, depending on how severe your disaster is, if you're actually completely rebuilding your environment, you may have to start with rebuilding the host and getting your VMs up and running. You'll generally start by redeploying your entire SDN infrastructure from scratch, if that's where you're coming from, or restoring those VMs from a backup. One thing that I didn't mention earlier, let me just go back to here, that very first step there after the start, back up the network controller VM or certs. So one thing that's important is this database we just backed up is encrypted using the certificates that are on the network controller. If you don't have those backed up, then your backup is useless. So very important first step. Back up at least the network controller VMs, which will have the certs, restore those, and then restore the new database on top of it to get the database consistent. Or go and just back up the certificates for the network controller in the cert store on those machines. So once you've done that, the first line is just redeploying everything from scratch. There won't be anything. It'll be basically an empty set of network controllers. You then need to stop the network controller host agents and all the southbound devices, because if these devices are trying to push information into the controller at the same time as doing the restore, you could get some inconsistency in some of the state. So the general recommendation is stop everything now, do the restore, refresh VMM. VMM recently in UR3 added the ability to do some do some refreshing of the network controller. So you'll use those VMM commands to do the refreshing. They've updated their documentation as well in UR3 of this year. Get the configuration state. If it's invalid, then you may need to do some manual reconciliation of your objects, meaning VMM and the controller may be inconsistent, especially if, for example, when you did your rebuild, you have a different number of hosts. Now things may have moved. You may have to do some manual fixes of the objects themselves. Hopefully that won't happen. And then once that's done, then you got everything up and running again, then do another backup so you have a current backup again. So you need to test this process to make sure it works. Let's actually just go and do a quick restore of one of those backups that I took earlier. We'll switch over. Now the restore process itself, the actual restore, once you kick it off, takes about 10 minutes. So we're not going to go through the whole thing. I'll just show you the script that I use. The script basically, I have it automated where I have some arrays that have my host name, my host, muxes, and gateway, so I know which ones to stop. And then I basically go through and I use a combination of VMM PowerShell to get the VM and suspend the VM. So I pause the VM for the gateways. I stop the host agent services on the hosts. And I stop the mux service on the mux VMs. And then doing the restore is simply a matter of getting the credentials that you use for the share. So you have those should already be in an object. You did the backup with those credentials. And then creating a restore object that's very similar to the backup object. And they do new network controller restore. And then you wait. It takes about 10 minutes. We'll kick it off. It's going to do the stop, and then it's going to do the restore. Now, it's normal when you do the query, because what the script is going to do is it's going to kick off the restore with that new network controller restore at the top, and then it's going to do a get network controller restore of that object again and look at the provisioning state. When it gets succeeded, that means it's successful. But before that, it'll say either updating or you'll get an error. At times, the restore process is actually going to be restarting a lot of those microservices as it's updating their databases. It's going to be restarting them. And if it's restarting some of those services when you query this, you'll get an error at that time. So it's normal to get an error when you do the get network controller restore initially. Eventually, it will go to the updating state, and then it'll eventually go to succeeded. So we're not going to wait the full 10 minutes. You'll have to take my word for it that this will complete. If you actually download the deck, I have the full video in the deck, so you can actually see a recording. This is a live demo, though, so we're not going to wait for it. All right. Quickly, monitoring. There's so much resiliency. If things go down, you may not know it unless too many things go down, in which case your customers will start telling you that things aren't working. We have a management pack for SCOM at that akka.ms/sdnmp. You can download it, bring it into SCOM, and it'll monitor the network controller objects. You want to monitor the network controller, the gateways, and the muxes as Windows computers as well, just to make sure that the Windows state stays healthy. All right, last lesson. And this isn't so much a lesson as it is an excuse to talk about Windows Server version 1709. What's new? When do you use Windows Server 1709? The challenge with Windows Server 1709 for a lot of you is that once you get on this semi-annual train, you have to stay on the semi-annual train until the next long-term servicing release, which means you have to update every 6 months, which for a lot of you, is not something you can do. Now, some of you, though, some of what I've heard is that you'll keep your, your real production and critical workloads running on the long-term servicing, the Windows Server 2016 that's very stable, has had lots of updates and continuing to get updated, and you never have to touch that again until it goes out of service 10 years from now. But you may deploy a small cluster of 1709 for those workloads that really need these new features. One of those new features may be encrypted virtual networks, the ability to have encryption take place automatically when two VMs on the same subnet send to each other. You have a legacy application you want to put in this environment. That legacy application is not the most secure. You can add a layer of encryption on there, and so you're protected from, at least the network admin in this case, from being able to get a hold of that traffic. Another thing we added is the ability to do logical network ACLs. Previously, we could only apply the ACLs, the security policy for firewall, to virtual subnets and network interfaces. Now we can apply it to logical networks. If you have a logical subnet, those firewall rules will get applied to any VM, any SDN VM that's connected to that subnet. Now that subnet may represent a VLAN that may extend outside of your SDN environment. Those machines obviously won't get those ACLs, so there is a little bit you have to be careful about there, but you can't put those ACLs. And then finally, something that a lot of customers have been asking for, egress bandwidth metering. This is the ability to basically keep track of how much traffic going outside of the SDN environment is being used. So that's mostly for billing purposes. If you're a service provider, that's very important. So encrypted virtual networks, well, this is basically, like I said, it encrypts within the same subnet. See a lot of red arrows. Those are the paths that are not encrypted, including going to the gateway. So this is kind of our first step towards encryption. We're going to expand what we're able to encrypt over the course of the next set of semi-annual releases. But here, at least our first step, you enable encryption on a subnet. It uses DTLS-based encryption, so everything after the MAC address of that packet that the VM sends gets encrypted automatically. It's completely agnostic to the operating system that's running in the guest. So it could be Linux, it could be Windows, it could be any of the operating systems that are supported on Hyper-V. You don't have to touch the guest OS at all. It's all done transparently by the virtual network. You do have to have a certificate installed on every host to be able to do the encryption for both encryption and decryption. You can use the same certificate for all tenants if you want. That's OK. Or you can do a unique one per tenant. Let's quickly jump into a demo and see this in action. Oh, I got 4 minutes. OK, that's good. Actually, I'm going to do the video due to time constraints. I do have a live demo. If anyone wants to stick around and want to see it live, I will do that. Let's just jump into the video, since that's the quickest way to get this done. So here's my environment. I've actually already installed the certs on here. I'm first doing a ping just to show here's a bunch of traffic, and did a query that shows that with Wireshark, Wireshark is actually querying the host network adapter, so it shows everything that gets sent on the wire. You can see I have a bunch of HTTP traffic that's unencrypted. You can see my pings were unencrypted. Those are going across the wire. So now I'm going to go onto my VMs, or my host, and you can see I have my encryption certificate there. It's called my network is the subject name, and you can see that I have it in both the root and my store of the host. We will have, as of next week, this scripts and instructions for how to create those certificates on docs.microsoft.com. Here you can see we're querying the virtual network. Just look at the properties real quick. You can see I have 3 subnets. You can see there's a new property right there on each virtual network called encryption enabled. It's set to false currently. You can see also up above, just scrolled off at the very top, encryption credential. That's a credential object that will contain the thumbprint of that certificate that's going to get used. What we're doing now is running a script that's going to create that credential object, which will contain the thumbprint. That's that 2BB big hex string you see there. We got that from the query we just made. And then we set the subnet to true to say enable encryption. We now do our ping again, and now you notice the Wireshark shows something very different. You can see it's all just showing the MAC address. You'll see it's still the VXLAN still there, but if you look at the inner packet, you'll see that once you get past VXLAN and the MAC addresses, you just have data. And that's all that anybody can get off the wire. So that's really cool. We do it automatically when 2 VMs on the same subnet that are marked for encryption send to each other. If those VMs send outside of that subnet, it's not encrypted. So that's by design. It automatically unencrypts if you're going out through NAT. If you want to do those restrictions further to basically say you can only talk to an encrypted machine, you can apply ACLs to enforce those restrictions. Fabric ACLs, I'm not going to talk too much about these, but basically more ability to lock down your infrastructure. Being able to put even ACLs on the host VNIX is something we've tested, made sure it works as well. Finally, egress bandwidth metering. We have a couple new properties on the virtual network. On each subnet, we have the build egress bytes and unbuild egress bytes. Those are basically counters that count how many bytes were sent from the VMs on that subnet. You can control what's considered unbuild by basically defining a subnet on the virtual network properties, unbuild address ranges. You can have subnets that are excluded from the build bytes because there may be services within the data center that are outside the virtual network that you don't want to build a customer for. And so you can put the subnet that those services are on in the unbuild address range, in which case you won't be building your customers for accessing those subnets. Just do this quick demo. This is the last one. And here I'm just going to query the virtual network, and you'll just see those properties where they are on there. So if you look, we'll scroll up. You can already see right at the top, unbuild egress bytes, build egress bytes. This subnet, they're all zeros because there aren't any VMs connected to it. Scroll up to my first subnet where I have my VMs. There you can see the build and unbuild are set. They have values that have been ticking. And you can see the unbuild address range right in the middle there, the 10.0.0.0.8 is basically excluding the entire data center range from getting build. Those counters get updated about every 4 minutes, so that's how often. So if you query it again immediately, you won't see a change, but after about 4 minutes, you'll see that change. That's egress bandwidth metering. With that, these are the lessons. I hope you learned something that you found useful. I want to thank you for spending your last few hours of Ignite here with me and all of us together. So remember those feedback links, SDN_feedback@Microsoft.com if you need more info. Please let us know. Be happy to help you get your deployments up and running and be successful. Please fill out an eval, and thank you for coming, and have a safe trip home wherever you're off to after today. So thanks.